Loneliness doesn't just hurt your feelings. It physically rewires your brain's neural pathways. Scientists discovered isolation triggers the same brain regions as physical pain. Your mind literally treats loneliness like a wound that never heals. Research shows chronic loneliness alters your prefrontal cortex, the command center for decision-making and social behavior. When you're isolated for extended periods, your brain enters survival mode, reshaping itself to perceive threats everywhere. Psychology says this isn't weakness, it's evolution. Your ancestors who feared isolation survived because groups meant safety. Today, that same mechanism backfires. Studies from the University of Chicago reveal lonely individuals experience heightened activity in the amygdala, your brain's alarm system. This hypervigilance makes you scan for danger in neutral social situations. A colleague's neutral expression becomes a glare. A delayed text becomes rejection. Your brain doesn't make you paranoid. It's trying to protect you from a threat it perceives as life-threatening. Neuroscientist John Cacioppo discovered loneliness triggers stress hormones comparable to severe anxiety disorders. Cortisol floods your system continuously, keeping your body in constant fight or flight mode. This hormonal cascade doesn't just affect mood, it rewires neural connections in your hippocampus, the memory center, making you remember negative social interactions more vividly than positive ones. Your brain literally creates a negativity bias, filtering reality through a lens of social threat. Functional MRI scans show isolated brains process social information differently than connected ones. The temporoparietal junction, crucial for understanding others' perspectives, shows reduced activity. You lose the ability to accurately read social cues, creating a vicious cycle where isolation breeds behavior that pushes people further away. Your brain craves connection like it craves food. Neuroscience reveals social pain activates the dorsal anterior cingulate cortex. This is the exact region that lights up during physical injury. When someone excludes you, your brain doesn't distinguish between emotional and physical harm. Both register as survival threats, requiring immediate attention. Research demonstrates this neural overlap explains why rejection feels genuinely painful. Evolution wired social connection as a biological need, not a psychological preference. Studies on prisoners in solitary confinement show measurable brain deterioration within weeks. The anterior cingulate cortex shrinks. White matter integrity decreases. Cognitive functions decline rapidly. Your brain needs social interaction to maintain structural health the same way your body needs vitamins. Psychologist Matthew Lieberman's research proves the default mode network, active when your mind wanders, primarily simulates social scenarios. Even at rest, your brain rehearses conversations, predicts social outcomes, and processes relationship dynamics. Isolation starves this network of real-world data. Without actual interactions, your social simulations become increasingly distorted based on fear rather than reality. The brain compensates by amplifying threat detection. Mirror neurons, which help you understand others' emotions, become oversensitive during loneliness. You project hostility onto neutral faces because your isolated brain assumes the worst. This neurological shift isn't conscious. You can't think your way out of it. The rewiring happens beneath awareness, in primitive brain structures, evolution designed for group survival. Loneliness restructures your reward system in devastating ways. Your ventral striatum, which processes pleasure and motivation, shows reduced activation to social rewards. Research shows chronically lonely people experience less dopamine release during positive interactions. The brain stops finding connection rewarding because isolation has recalibrated what feels good. This creates a terrible paradox. You need connection desperately, but your brain no longer finds it pleasurable. UCLA studies reveal this reward dampening happens within months of sustained isolation. The nucleus accumbens, your motivation center, requires social feedback to maintain sensitivity. Without regular positive interactions, it becomes desensitized. Psychologically, this manifests as social anhedonia, the inability to enjoy socializing even when opportunities arise. You might attend gatherings but feel numb, disconnected, unrewarded. Your brain's dopamine pathways have been reshaped by prolonged isolation. Neuroplasticity cuts both ways. The same brain flexibility that allows learning also permits destructive rewiring. Oxytocin, the bonding hormone, follows similar patterns. Isolated individuals show reduced oxytocin receptor density in brain regions governing trust and attachment. Your capacity for connection literally shrinks at the cellular level. The brain prunes unused neural pathways. If you're not regularly activating social circuits, those connections weaken and disappear. This isn't permanent, but reversal requires deliberate, sustained effort against powerful neurological currents. Your immune system suffers direct consequences from loneliness-induced brain changes. The hypothalamic pituitary adrenal axis becomes dysregulated during chronic isolation. Research shows lonely individuals have suppressed immune function comparable to chronic stress disorders. Your brain's interpretation of social isolation as life-threatening triggers inflammatory responses. Cytokine production increases, creating systemic inflammation linked to cardiovascular disease, diabetes, and accelerated aging. Psychology says this mind-body connection operates through clear neural pathways. The vagus nerve, connecting brain and body, transmits loneliness signals that alter immune cell behavior. Studies from Carnegie Mellon University demonstrate isolated individuals are more susceptible to viral infections. Your brain's social pain doesn't stay psychological. It translates into measurable biological deterioration. The insula, processing bodily sensations and emotions, shows altered activity in lonely people. This creates distorted interoception. You misread your body's signals. Hunger feels like anxiety. Fatigue feels like depression. The brain loses calibration between physical states and emotional interpretations. Sleep architecture changes dramatically with prolonged isolation. Your brain enters lighter sleep stages more frequently, reducing restorative deep sleep. This creates cognitive fog, emotional volatility, and impaired decision-making. The cycle reinforces itself. Poor sleep worsens social anxiety, making connection more difficult. Loneliness triggers catastrophic thinking patterns through specific neural mechanisms. Your anterior prefrontal cortex, responsible for rational assessment, shows decreased activity during isolation. Simultaneously, the amygdala becomes hyperactive, flooding consciousness with threat-based interpretations. This imbalance creates cognitive distortions indistinguishable from anxiety disorders. Research demonstrates lonely individuals make systematically pessimistic predictions about social outcomes. Your brain generates worst-case scenarios automatically, a survival mechanism gone haywire. Psychologist Louise Hockley's work reveals this negativity bias operates below conscious awareness. You're not choosing pessimism. Your rewired brain presents it as reality. The dorsolateral prefrontal cortex, governing executive control, struggles to override these automatic negative thoughts. Neuroimaging shows reduced connectivity between rational and emotional brain regions during loneliness. The thinking brain can't properly regulate the feeling brain. This neurological disconnect explains why lonely people often recognize their thoughts are irrational but can't stop them. Cognitive behavioral therapy works by strengthening prefrontal control over limbic reactions, essentially retraining neural pathways isolation has distorted. The brain's narrative centers also shift during loneliness. Your left hemisphere constructs stories explaining your isolation, stories that typically blame yourself or others. These narratives become self-fulfilling prophecies. If your brain decides you're socially incompetent, it filters experiences to confirm that belief. Your brain can heal from isolation, but recovery requires understanding neuroplasticity. The same mechanisms that rewired your brain toward threat can rewire it toward connection. Research shows even brief positive interactions begin reversing loneliness-induced changes within weeks. Your hippocampus can regenerate neurons through neurogenesis. The prefrontal cortex can rebuild connections to emotional centers. The reward system can relearn to find pleasure in social engagement. Psychology says the key is consistency over intensity. Small, regular positive interactions create more lasting neural change than occasional intense socialization. Studies demonstrate volunteering or structured social activities provide the repetition needed for neurological restructuring. Your brain needs predictable social experiences to recalibrate its threat detection systems. Mindfulness practices help by increasing awareness of automatic negative thoughts, giving the prefrontal cortex opportunity to intervene before the amygdala hijacks response patterns. Physical exercise accelerates brain healing from loneliness. Movement increases BDNF, brain-derived neurotrophic factor, which supports neural growth and plasticity. Combined with social interaction, exercise creates optimal conditions for rebuilding damaged pathways. Your brain remains plastic throughout life. Isolation's neural damage isn't permanent. The human nervous system evolved remarkable capacity for recovery. Understanding the neuroscience removes shame. Loneliness isn't personality failure. It's a brain state subject to change through deliberate action. Loneliness physically rewires your brain, activating pain centers and triggering survival mode. Your prefrontal cortex loses control while your amygdala amplifies threats in neutral situations. The reward system stops finding connection pleasurable as dopamine pathways reshape around isolation. Chronic loneliness suppresses immune function and creates systemic inflammation through neural pathways connecting mind and body. Your brain generates automatic negative thoughts because connectivity between rational and emotional centers weakens. Sleep deteriorates, memory becomes negatively biased, and social skills atrophy as unused neural circuits get pruned. The temporoparietal junction struggles to read others accurately, creating a vicious cycle where isolation breeds behavior that drives people away. Research shows these aren't psychological weaknesses, but measurable neurological changes comparable to physical injury. Your brain treats social pain identically to bodily harm because evolution wired connection as biological necessity, not preference. But neuroplasticity offers hope. The same flexibility that allowed destructive rewiring enables healing. Small, consistent positive interactions rebuild damaged pathways over time. Exercise, mindfulness, and structured social activities accelerate recovery by supporting neural growth. Your prefrontal cortex can regain control over the amygdala's threat responses. The reward system can relearn to find pleasure in connection. Understanding the neuroscience removes shame and provides a roadmap for reversing isolation's neural damage through deliberate, informed action. Your brain is waiting to reconnect, but it needs your help. Start small. One genuine conversation this week creates measurable neural change. The neuroscience proves you're not broken, you're rewired. Every positive interaction begins reversing the damage isolation created. Understanding this science is the first step. Taking action is the second. Your prefrontal cortex needs practice overriding the amygdala's fear responses. Give it that practice. Reach out to someone today. Leave a comment sharing your experience with loneliness. And that simple act starts rebuilding social neural pathways. Your brain's plasticity means change is always possible. The question isn't whether your brain can heal from isolation. Science answers that definitively, yes. The real question is whether you'll take the small steps necessary to activate that healing. Subscribe for more neuroscience-backed strategies to understand and optimize your brain. The next video might contain the insight that finally clicks for you.